Hello, friends. Welcome to yet another video in our arithmetic series. And today the main topic is averages. Yes, once we understand averages, then weighted average, and after understanding weighted average, it will lay the foundation for the next very interesting and very good different topic which you might not have done in schools. That is allegation. Okay. Now, the word average is not a new word for you. We have used this word so many times, yeah, in our daily life, correct? And knowingly or unknowingly, everybody has a good enough sense about this word average, correct? All right, so let's see this in detail at the end of this video. I hope you will be very, very strong with this concept and ready to face any question based on it. So keep your pen and paper ready, pen and notebook ready to take the notes. Yeah, thank you. So first is arithmetic mean. Another word for averages is nothing but means, correct? First of all, you might be wondering now, why do we need averages? Why do find averages? Yes, one very simple logical reason. If I want to replace all the different numbers which are there in a group of numbers, I want to replace all of them by a same uniform number. So what should that same number be? What should that uniform level be? That is where the concept of averages comes into picture, correct? We need one uniform figure, like one representative value. All right, see this example. We have monthly rainfall in Colombo in 2012. Every month different amount of rainfall happened, and I want to replace all of them by the same level. If I want to compare for the entire year, what will be the average rainfall? That's it. Knowingly or unknowingly, I use the word average straight away. It is like instilled in our mind. Okay, so simple average or arithmetic mean, what's the logic? Add all the values, divide that total equally across all the values. So total of all the values divide by number of values. That will be the uniform level, friends. So when we add all these, the rainfalls in all the months. So total rainfall is 3000 divided by 12. There are 12 months. So average rainfall for the entire year can be visualized or assumed at 250 mm. Okay, 250 mm. This is how we find arithmetic mean or the simple average. Generally, it should be used when the denominator is constant. Okay, when the denominator is constant. All right. Then one more way, that is called as assumed mean method. Yeah. Suppose if I, out of all these values, I choose a rough figure, maybe slightly towards middle values, let's say 200. So I assume that let the average be 200, correct? Then find all the deviations or the differences of the given numbers from this assumed mean, assumed value. So all those values 370, 550, 600, 320 were above 200. And these values are below 200. So they will have negative difference, correct? Then add all these differences. Interestingly, you will see that so many differences will get cancelled out. See, 20 got cancelled, 120 is getting cancelled, yeah, 170 getting cancelled. Then wow, so finally adding all these four, we are getting 600, and there were 12 values. So 600 divided by 12, 50. Okay, yes, cool. So assumed mean was 200. So actual mean will be 50 more than this assumed number. Yes. So the actual mean is 250. This is also one of the interesting ways wherein you are not dealing with the bigger numbers. You're just dealing with their differences. And a lot of times it happens that so many differences will get cancelled among themselves. Yes. Okay. So this was your assumed mean method. All right, friends, understood this arithmetic mean by assumed mean method? Okay. Now, see, as you just now saw, the lowest value among all these values was like 130, sorry, 100, correct? And the highest was 600. So when there are unequal values coming down at equal level, so what is happening? Higher values tend to lose, and that excess is provided to lower values to come at some level. Means that uniform level will lie somewhere in between the highest and the lowest. So remember that the average of any set of values will always lie between the highest and the lowest values. Correct? Average or mean will always be more than the lowest value and will always be less than the highest value. Correct? This will help you later when we do allegation. Okay, remember this. All right. Now, let's understand some logical behavior of average to do some questions logically. Yeah, see this. There are some set of people who have some weight, so they have some average weight as a group. Now, when a new person who joins the group is like more than the current average, so of course the new average will definitely increase, right? So new average will be more than the current average. Similarly, if a new person who joins the group is having a weight less than the current average, correct, the new average will definitely fall down. Everybody will have to sacrifice something to give that lower value, and then they will come at the uniform level, correct. But that fat person who is having more weight will not only maintain the current average but will give extra to all of them, so the uniform level will go up that way. Okay, similarly, when you are deleting something, so this particular group of people has some average age. Now if you remove a person who is like whose age is less than the current average, see that child got removed, so the new average will obviously increase, right? Yeah, cool. But when you remove a person whose age is more than the current average, of course the new average will fall down, correct. A bigger value was removed from the group. Okay, so let's summarize this. So when you add a value which is more than the current average, see the first column, the new average will increase, right? And if it is less than the current average, the new average will reduce. Now, if you delete a value which is more than the current average, yes, the new average will reduce. And if you delete a value which is less than the current average, the new average will increase. Correct. Remember this to perform some operations logically, mentally, without touching the pen. Okay. Yes, friends. All right. Let's go ahead to the next topic, that is weighted average. Suppose somebody tells you scored 60% in maths, 70% in science, and in languages that student scored 80%. So what is the average score overall? Will you just add all of them and divide by 3? This should be valid only if all three subjects have same base. Let's say if all of them are like out of 100, then this is perfectly all right. But what if they are out of different bases? For example, maths is out of 200, science is out of 300, languages are out of 500. Then of course this answer will be wrong, right? Yes, because 60% of 200, that is 120. 70% of 300 will be 210. 80% of 500, so 400, right? If you add all this, divide by total marks as a base is 200 plus 300 plus 500, right? That is how you used to calculate your score, isn't it? Into 100. So after simplifying this, we are getting 73%. Yes. So this is only called as weighted average. So basically, you can also do it like this. The base marks were 200, 300, 500. So you can take it as a ratio. You can reduce it in the ratio form. So 2 is to 3 is to 5. You can just simply do 60 into 2 plus 70 into 3 plus 80 into 5 divided by 2 plus 3 plus 5. That is taking 100 common from numerator and denominator and cancelling out that 100. So this is your weighted average. It's like 60% will be added twice, right? 100 plus 100 is a base. If you take 200, if you split that into two equal groups, 100, 100. So 60, 62 times, 70, 70 will be added 3 times, 80, 80 will be added 5 times. So everybody has its own weight. If all these weights would have been equal, let's say 2, 2, 2 each, or 3, 3, 3 each, or 5, 5, 5 each, then ultimately if you realize you can take that thing common from the numerator and denominator, then weighted average will simply become the normal simple average, like that 60 plus 70 plus 80 divided by 3, if all the weights are equal. Yeah, cool. So this is your weighted average, friends. Now see, if a simple sample question to understand, if 3 kgs of tea powder costing 10 rupees per kg is mixed with 2 kgs of tea powder costing 25 rupees per kg, what will be the average price of the resulting mixture? Simple. So 3 kgs at the rate of 10 rupees for every kg. So total cost will be 3 into 10, and their total cost will be 2 into 25. Divide by total quantity 3 plus 2. Yes. So ultimately this comes down to 16 rupees per kg. That is the average. Yeah. Good. Now, one more interesting and very logical method to do this also. See, this is a conventional method wherein you must have understood everything properly. Now, a new method inspired by a game in the gardens which we play, children's play, seesaw. I'll call it as lever method. See, this lever is perfectly horizontal. So this is your balancing point, exactly in the middle, right? This will remain horizontal as long as we have same weight on both the ends. You can simply ignore the weights. It will still be horizontal, and average will be exactly in the middle. That is equidistant from both the ends. One more way of saying equidistant from both the ends, right? Cool. Now what? Did you see? If there are unequal weights, correct? Unequal weights. So obviously the lever will bend down towards heavier side. I want to make it horizontal again. I don't have an option of changing the weights. So what will I do? Shift this balancing point to the heavier side and make it horizontal again by giving more support that side. Isn't it? So what this logically tells you? Yes, the resultant average, that is the balancing point here, will always be closer to the heavier side and away from the lighter side. Yeah, this will be the distribution. So distribution is unequal because weights are unequal. But in that unequal distribution also, how should the planning be? The resultant weight should be closer to the heavier side, resultant average, sorry, and away from the lighter side. This simple illustration tells you this. We got this learning from this example that average should be closer to the heavier side in case of the weighted average method. Let's apply this in the question. Yeah. So here we had 10 rupees per kg. That side we had 25 rupees per kg. And the weights were like 3 kgs and 2 kgs, unequal weights. If the weights would have been equal, like 3 kgs on both sides or 2 kgs on both sides, the average would have been exactly in the middle. Exactly in the middle means, what is the gap of 10 and 25? Yes, gap is 15. And I will distribute this equally because weights are equal, and equally means ratio 1:1. That is 7.5 each. So the resultant balancing point would have been at 17.5. At least did you understand this? That was nothing but 10 plus 25 divided by 2. 35 divided by 2. यही होता था ना अगर weights equal होता तो. अब equal नहीं है. So now the gap of 10 and 25 is 15. Distributing the ratio of the weight, that is 3 kgs and 2 kgs. This is already in the most reduced form. So if I split 15 in the ratio of 3 and 2, what will be the actual values? You can say it is 3 parts, 2 parts, or you can say 3x and 2x. So 5x is 15. So x is 3. So 3x will be 9 and 2x will be 6. Also, I hope you remember how will I apply this 9 and 6 distribution? Yes, in such a way that the resultant average is closer to the heavier side. Now, which is heavier side? 3 kgs. If I give 9 this side and 6 this side, so wrong, no? It is away from the heavier side. So 6 should come here and 9 should go there. So 10 plus 6, 16, or 25 minus 9, 16. So the required average is 16. Isn't it interesting, friends? Lovely logic, right? Same gap you are distributing unequally simply because weights are unequal. After getting those unequal numbers, those two split up, those two numbers after applying the ratio of the weights, distribute in such a way that the average should be closer to the heavier side. Means you'll always have to flip it because heavier side will always have the higher number. Higher number should be given to the lighter side so that it becomes away from the lighter side. Yeah. This is the funda, friends, of lever method. Correct. See once again. So the gap was 15. It should be distributed in the ratio of 3:2, but apply in the ratio of 2:3 because it should be closer to the heavier side. So 2 should come to this side, heavier side, and 3 should go to the lighter side. So 15 will be distributed in the ratio of 2:3. So 6 and 9. So 6 more than 10 or 9 behind 25. 9 less than 25. So ultimately, our weighted average is 16 rupees per kg. Okay. Here only I'll tell you one more method, friends. One more thought. Suppose it was given to us that one variety is 10 rupees per kg, other variety is 25 rupees per kg, and I want the resultant to be 16 rupees per kg. So in what ratio should I mix to get that desired average? In what ratio? Now I'm looking for ratio. In lever method, we were looking for weighted average. After mixing, what is the resultant average? Now reverse. Resultant average is known to me, target is known to me. I want to know in what ratio should I mix. So see, reverse of this gap is 9 and this gap is 6. But how we had applied gap? We had switched the values, right? Means this gap is 6 is not because of the weight from the 10 ka side. So it will go to that original side. And this 9 ka gap is not because of this wala weight. Exchange hua tha na, so 9 should come to this side. The ratio is 9:6, or if you reduce 3:2. Yahi ratio tha na, 3:2. And this is only called as allegation. Yahi hai allegation. Understood? So when do we use allegation? Yes, when we need the required ratio in which the two things should be mixed to get that desired average. All right, getting it? Superb. Stay tuned. So what is allegation? So ultimately it is nothing but the method of finding the ratio in which two or more ingredients should be mixed in order to make a mixture of a desired proportion. Okay, this is the aim of allegation. So see the sample question again. In what ratio should you mix two varieties of tea powder? Yeah. One costing 10 rupees per kg and other costing 25 rupees per kg. So as to get a mixture at an average price of 15 rupees per kg. Ratio is asked, first hint. Resultant average is given to us. Yes. So the gaps, 5 and 10, but they were after switching over because heavier side, average should be closer to heavier side. So 5 should go to that side. Yeah. So the ratio of 5:10 was 1:2. Switch it again to get the old ratio back. Means 2:1, right? Mixing should happen in 2:1. See? Yeah. This gap is 5. It should come this side, and that gap is 10. So they should come this side. So the ratio is 2:1. Correct? So values were 10 and 25. Average was 15. So ratio will be This is 5, this is 10, so 2 is to 1. So 2 parts of 10 rupees per kg, 1 part of 25 rupees per kg. Correct? Also remember few key things. First thing, when do we need to think about allocation? When ratio is asked. Then always think of allocation as one of the best approaches. Second, the ratio which you get at the end is ratio of what? Is it the ratio of the values 10 and 25? Of course not, right? Ratio of 10 and 25 is 2 is to 5. Why will I have to do all this? This is the ratio of kgs, that is the quantity which is there in the denominator over here. So whenever we apply allocation, the ratio which you get at the end is ratio of denominator quantity. Okay. Ratio of denominator quantity. Third, when you have 3 or more quantities, then you'll have infinite ratios, infinite possibilities of ratios. This we can explore in the questions. So know this much about allegation minimum. So when ratio is asked, then think of allegation, and the ratio which you get at the end is the ratio of the denominator quantity. And for 3 or more quantities, if you find the weighted average, and if you want that desired weighted average, the required ratio can be many options. There can be many such options. There will be infinite such possibilities. All right. Okay. Cool. One more question in this, friends. Just check this variety. A vessel contains wine and water in the ratio of course, 2 components are there, so there must be ratio 1 is to 5. Another vessel contains wine and water in the ratio 7 is to 11. Again, the question is, in what ratio should the contents of the 2 vessels be added so as to get the wine and water in the ratio this? So this is the target, this is the average. Now, how will you deal with this? Say there is a ratio, not a single number. That is the only change, right, in this question. If you remember, one thing doesn't change in ratio. What is that? Fraction of any component. Remember, what is fraction of any component? That component divided by total. So if wine is to water is 1 is to 5, so don't you feel wine represents 1/6, 1 out of 6, isn't it? 1 out of 1 plus 5. Similarly, in another vessel, wine represents 7 out of 7 plus 11, so 7 out of 18. And resultant average is 5 out of 5 plus 13, so 5 out of 18. And then the same process. Now, just ensure that you make the denominators equal so as to have the comfort in the subtraction of the fractions. So 1 by 6 is same as into 3, right? That is 3 by 18. So 7 by 18 minus 5 by 18 is 2 by 18. You can ignore 18 now. 5 by 18 minus 3 by 18, 2 by 18. So ultimately upon 18 gets cancelled because we're taking ratio. And 2 is to 1 further can be reduced as 1 is to 1. So final ratio is 1 is to 1. All right. I hope you know now. You might be wondering, can we only take one component? Then how to know which component? No. The final answer will be same. Whether you take wine throughout or you take water throughout, as it is like homogeneous mixture. Yes. You can do by water also. In the first vessel, water is 5 by 6. Yeah. In second one, it is 11 by 18 and resultant is 13 by 18, right? Same thing again. This will become 15 by 18. So 15 minus 13, 2 by 18. 13 minus 11, 2 by 18. 2 is to 2, 1 is to 1. Same answer. Got it? No change. All right. Understood, friends? Okay. Let's go ahead and see other methods of computing the mean. If you remember, what was the main aim behind finding the average? We want to convert the different numbers into same numbers. We are looking for that uniform level. There are 3 ways to achieve this. One of the very famous and most frequently used method is arithmetic mean. So we saw everything about it. All right. There are 2 more based on some situations. You will see the usage of those 2 also. The next is like geometric mean, short form GM. This is the structure of finding the geometric mean, the formula. nth root of product of these n values. So if there are only two numbers, let's say a1 and a2, product of two numbers, square root. If there are three numbers, so cube root of product of those three values. Okay, and so on. This is the structure to find geometric mean, the formula. I hope you have noted. All right. Example. If there are three numbers 10, 20 and 30, तो कैसे करोगे? Yes, cube root of product of these three numbers. So 10 into 20 into 30 ka cube root. 6,000 ka cube root, which can be written as 6 into 1,000. So 1,000 cube root, you know, is 10. So 10 into cube root of 6 will be the geometric mean. So whenever you are having multiplication numbers in the form of multiplication, all are different. For example, if I have x into 4 into 9, I don't want to disturb this product as 36. This is 36 only, right? 9 into 4. I want to make it equal. I want to split it into equal numbers. So what will I do? Into 6 into 6. So I have converted these different numbers into the same number. How did I get this? I just took 4 into 9 and square root of that. This is geometric mean. Okay. So when the values are in the form of product and you want to make them uniform, think of geometric mean. It's also called as multiplicative mean. And our arithmetic mean is additive mean. We should use arithmetic mean when the denominator has constant numbers, same numbers. And when the numbers are in the multiplication form, so multiplicative mean, that is geometric mean, will come into picture. And last one, harmonic mean. The structure is this. Understand the structure? Number of terms in the numerator. Number of terms in the numerator, and the denominator is sum of what? Reciprocal of each term. So if there are two terms, so A1, is it correct? Of course not. Number of terms upon sum of reciprocal of each term. Yeah, which on simplification will look like this. There are three terms, let's say ABC, so 3 upon 1 upon A plus 1 upon B plus 1 upon C. Then you can simplify further by taking LCM and all. But know the basic structure. Generally, in average speed-based questions, you will see the usage of this. Now, when should we use this? When the numerator is constant. So when the numerator is constant, think of harmonic mean. Because of its nature, we can also call it as a reciprocative mean, as we add reciprocal of every term in the denominator. So if you see speed is equal to distance upon time, so whenever you go for average speed, if you find that every time the distance traveled is constant, think of harmonic mean. And denominator is time. Every time the time taken is constant, then think of arithmetic mean to find the average speed. Remember this. In our next videos based on time, speed, distance, we will use this logic again. Okay, got it? Let's see some numbers to understand. Find the harmonic mean of 4, 8 and 9. So three numbers. So 3 will be there in the numerator. In the denominator, what will be there? Yes, tell me. Super. 1 by 4, 1 by 8, 1 by 9. Simplify this. Ultimately, you get 216 upon 35. Okay. Got it, friends? All right. Now, if you take a set of positive real numbers, for the same set of positive real numbers, okay, the order between the AM, GM and HM is like this. So AM will be either more than or equal to GM, which will be either more than or equal to HM. Yeah. Now, specifically, equality will hold true when the numbers themselves are equal. Remember the main aim behind finding average. If the numbers are different, then we try and make them same by using these three approaches: AM, GM, HM. When the numbers themselves are equal, why will I try to make them equal? Of course. So if the numbers are same, you find their AM, GM, HM, and you will find that all of them will be same. For different numbers, we have this strict inequality. AM will be higher than GM, which will be higher than HM. Remember this thought We will be using this in algebra topic maxima and minima. The videos are already there. You can go and check there right now after this video. So it is fresh. You can connect AM more than GM more than HM for distinct numbers, for different numbers, and equality hold true for equal numbers, for the same set of numbers, equal numbers. All right, understood? Okay, I hope we have noted everything, proper notes, and you have followed whatever we have discussed in averages and allegations. So simple average, AM, GM, HM, weighted average, and then lever method and the allegation logic. Okay, all right. So thank you so much. Stay safe, take care, happy learning, keep learning. Thank you so much. Bye bye.